Welcome back. This video continues directly from What is AI Part 12, What is a LLM Basics. That video covered what a large language model is, how one is built, pre-training, alignment, and what happens the moment you send it a message, inference. If you haven't watched it yet, start there first. This video assumes that ground is already covered and goes further, placing large language models inside the wider AI story you've been building across this series, and going deeper into how you actually work with one day to day. Perceive, reason, learn, act. The same 4 words, a different meaning. Part 1 defined AI itself using 4 words. A system that perceives, reasons, learns, and acts. So does a large language model actually do those 4 things? Yes, in the sense the field has always meant them, a thin functional sense, and no, in the fuller sense, those same words carry for a human lived experience. Perceive means taking in structured input. A thermostat perceives temperature. A computer vision system perceives an image as pixels and patterns. An LLM perceives text as tokens. That is the whole sensory apparatus. No lived experience, only statistical relationships from training. A human eye sees differently. It recognizes expression, mood, and context. The same smile can mean warmth or deception depending on who is looking. The machine sees patterns. The person sees meaning. Reason means processing input to produce an output. In an LLM, the attention mechanism weighs every token against every other to arrive at a prediction. When a model shows it's working, it is changing its next prediction through computation. It is not deliberation. It is not belief. A human reasons differently. A doctor examining a patient draws on years of experience, intuition, and ethics. They consider what is not said and what the textbook does not cover. The machine predicts. The person decides. Learn means performance improves with data. Gradient descent adjusts parameters during training. Then the parameters freeze. The model does not update from this conversation. It holds the conversation in view, then loses it. A person learns differently. A student who makes a mistake adapts and carries the lesson forward. The learning is embodied. It changes how they think, not just what they output. The machine adjusts weights and stops. The person grows and adapts. Act for a plain LLM means producing text. It describes a step but does not carry it out. A large action model extends this to execution. It can click a button or complete a transaction. Recall from layer 3 that a model holds no persistent understanding of you between messages, only whatever seats inside the context window right now. That has a direct consequence worth stating plainly. Your prompt is not a suggestion to a system that already half understands what you want. It is the entire instruction set every single time. A human acts differently. They do not just execute. They respond, adjust, and take responsibility. A driver does not just follow a route. They react to traffic, make decisions, and own the outcome. The machine executes a sequence. The person acts with intention and accountability. An LLM does perceive, reason, learn, and act, but only at a functional level. It is not the human kind. Why large language models and why now? Each architecture follows the shape of the problem it is trying to solve. Images have a different structure from text and sequences have a different structure from either. CNNs were built for images, learning to recognize a shape regardless of where it sits in the frame. RNNs were built for sequences, reading one step at a time and carrying a memory of what came before. The transformer replaced that step-by-step reading with the attention mechanism from layer 1, weighing every word against every other word all at once. A large language model is what you get when you push that transformer architecture to an enormous scale on an enormous amount of text. Why push it that far? Because language turned out to reward scale in a way smaller models did not predict. A transformer trained on a modest slice of text can complete simple sentences, but the same architecture, trained on trillions of tokens with billions of parameters, starts doing things nobody explicitly trained it to do, holding a conversation, writing working code, explaining a concept it was never directly taught. Researchers call these emergent abilities, and they are the reason the field kept scaling up rather than stopping at a smaller, cheaper model. Put simply, an LLM isn't a new invention sitting apart from the rest of this series. It's the transformer architecture from earlier, scaled up until fluency turned into something closer to general capability. Why LLMs feel like the face of AI. Most of AI runs quietly, out of sight. A CNN is sorting through medical scans. A recommendation system is quietly deciding what you see next. A fraud model is silently blocking a suspicious transaction. All AI, all covered earlier in this series, and almost none of it visible to the person it's working for. A large language model is different. You type to it directly and it answers back in your own language on the spot. It is the one part of AI most people ever actually speak with, which is exactly why, for most of the public, AI and LLM have quietly become the same word, even though an LLM is only one room in a much larger house. In short, LLMs aren't necessarily the most important part of AI. They're simply the part with a face and a voice, which is why they're the part everyone notices. Not every language model is large. SLMs, LAMs, and LVMs. Large language model implies there's a smaller alternative, and there is. A small language model, or SLM, uses the same transformer architecture and the same training loop from this video, just at a fraction of the scale, millions or low billions of parameters rather than hundreds of billions, often trained or distilled from a larger model's knowledge. What it loses in broad, general fluency, it gains back in speed and cost. An SLM can often run on a single phone or laptop, answering instantly, with no data ever leaving the device. The trade-off is a narrower range of things it does well. Another variation is the large action model, or LAM, where an LLM's job ends at producing text, an answer, a draft, a plan written out in words. A large action model is built to carry that plan into action, calling other software, clicking through an interface, completing a multi-step task in the real digital world rather than simply describing it. Think of the difference between a guide who tells you exactly which bus to take and where to change, and a guide who simply takes your hand and walks the whole route with you. Both are useful. They are not the same job. A related variation is the large video model, or LVM, the same architecture and training loop again, but applied to video instead of text, predicting the next frame instead of the next word, or generating a short clip from a written description. Frontier models, the moving edge of what's possible. One more term worth knowing. A frontier model is simply whichever handful of models currently sit at the very edge of what's technically possible. The largest, most capable, most expensive to train, usually built by one of a small number of well-resourced labs. Being frontier isn't a fixed category, it's a moving line. Today's frontier model is tomorrow's ordinary baseline, once smaller, cheaper models catch up to a capability that used to require the very largest system available. In short, SLMs, LAMs, and LVMs describe what shape a model takes. Frontier simply describes whichever models are currently in the lead, for however long that lasts. That's the shape of where LLMs sit in the wider story. Today's frontier model is tomorrow's ordinary baseline, once smaller, cheaper models catch up to a capability that used to require the very largest system available. In short, SLMs, LAMs, and LVMs describe what shape a model takes. Frontier simply describes whichever models are currently in the lead, for however long that lasts. That's the shape of where LLMs sit in the wider story. The remaining question isn't how one is built, that's already covered, but how you actually get the most out of one once it exists. Layer 4, continued. Getting the most out of a model. The basics video already covered the first level choice, prompting, retrieval, augmented generation, or fine-tuning, and why prompting and retrieval get tried first almost every time. What follows goes deeper into that first cheapest option, prompting itself and everything that sits around it, why prompting is everything. The basics video already covered the first level choice, prompting, retrieval, augmented generation, or fine-tuning, and why prompting and retrieval get tried first almost every time. What follows goes deeper into that first cheapest option, prompting itself and everything that sits around it. Why prompting is everything. It costs real infrastructure and engineering effort, ongoing maintenance, and unless the model is fully self-hosted, it often still depends on a vendor's model somewhere upstream, which means private is a spectrum, not a single guarantee. In short, public buys speed and breadth at the cost of control, private buys control at the cost of speed, cost, and effort. And the right choice depends entirely on what is actually being put through it. Vague in, vague out, precise in, precise out. The same way the trader can only match a request as well as the request was actually made. Bottom line, because the model has no memory of you to fall back on, the prompt is not one input among many. It is the whole of what the model has to work with, which is exactly why how you ask matters as much as what you ask. Prompt engineering, crafting the ask deliberately. Prompt engineering, crafting the ask deliberately. Prompt engineering is simply the practice of shaping that instruction on purpose rather than leaving it to chance, giving worked examples of the output you want, stating the format up front, breaking a large ask into explicit smaller steps, naming the constraints that matter before the model starts generating. None of this is a magic phrase that unlocks hidden ability. It is giving the model's next token prediction the clearest possible runway to land on what you actually meant. Plainly put, prompt engineering is not a trick. It is the ordinary discipline of asking clearly, applied to a listener that cannot ask a clarifying question back unless you let it. Context engineering, beyond the single prompt. A newer, broader term sits alongside prompt engineering, context engineering. Where prompt engineering shapes the wording of one ask, context engineering shapes everything else sitting inside the context window at the moment the model answers. Retrieve documents from a RAG system, prior turns of the conversation, tool results, system-level instructions the user never sees. For simple question and answer exchange, careful prompting is often enough. For a simple question and answer exchange, careful prompting is often enough. For an agent or a retrieval-based system, context engineering is usually what actually decides whether the answer is any good, because the model can only reason over what has been placed in front of it. Distilled prompt engineering crafts what you ask. Context engineering curates everything the model can see when it answers, and for any system more complex than a single chat message, the second one matters more. For an agent or a retrieval-based system, context engineering is usually what actually decides whether the answer is any good, because the model can only reason over what has been placed in front of it. Distilled prompt engineering crafts what you ask. Context engineering curates everything the model can see when it answers. And for any system more complex than a single chat message, the second one matters more. A public model, the kind behind ChatGPT or Claude.ai, is like a village's shared well, open to everyone, but its water and everything drawn from it passes through infrastructure no single household controls. A private deployment is more like a borehole a single homestead digs and maintains itself. Whether that's a walled-off private version of someone else's model, kept out of anyone else's training, or a fully self-hosted, openly published model a household or organization runs on its own land. That choice is the sovereignty question in practice, not just in theory, A community that only draws from someone else's shared well has no say in what goes into that well next, or where the water it drew ends up being counted. Digging even a smaller borehole, trained and hosted locally, is one real way of keeping that control where it belongs. Does the company running it keep a copy somewhere? That is a different question entirely. A policy question, not a mechanical one, and it depends entirely on the provider's terms. Some providers log conversations for a period for safety and abuse monitoring. Some consumer free-tier products may use conversations to improve future models unless a person opts out. Many paid business and API tiers contractually exclude a user's data from training by default. There is no single true answer that covers every product, which is exactly why reading the specific data policy in front of you matters more than assuming. The plain take: the model's memory is wiped clean the moment your conversation ends, but the company running it may still keep a ledger of that conversation, and only their stated policy tells you for how long and for what. Private versus public GPT, the practical trade-offs. A public model, the kind behind a consumer chat product, gains you instant access, no setup, the newest capability as soon as it ships, and low or no cost for everyday use. It costs you control. Your data sits under someone else's terms as just described. There is no guaranteed confidentiality for sensitive material. The provider can change the model's behavior without warning, and a community drawing only from that well has no say in what goes into it next. Closure. Let's bring this one home. An LLM perceives, reasons, learns, and acts only in the thin, functional sense that has always defined AI. It's the transformer architecture from earlier in this series, scaled up until fluency turned into something closer to general capability. It's the part of AI with a face and a voice, which is why it feels like the whole of AI, even though it's one room in a much larger house, and large is only one shape among several: SLMs, LAMs, LVMs, and whichever handful of models currently sit at the frontier. And once a model exists, the choices don't stop. How you ask it, prompt engineering and context engineering, shapes the answer as much as the model itself does, whose infrastructure it runs on, and whether the company behind it keeps a ledger of your conversations are practical questions worth asking of any AI product, not just this one. None of this replaces what basics covered. Pretraining, alignment, and inference are still the engine underneath. This is the rest of the picture, where LLMs sit in the wider story and what actually changes once you're the one holding the prompt. Thank you for watching this Artificial Intelligence Institute Africa AIIA video brought to you by Ubuntu Guild. Subscribe to our AIIA YouTube channel and to Cognify.